Like I said, when I talked about the syllabus, our first unit is comprised of a lot of stuff that you're going to find to be reviewed, particularly the stuff that we are going to talk about today. I think everything in section 1.2 you have already seen, and you've seen probably half the stuff in 1.1. So again, whatever questions you have, ask. Don't be shy. You are not an imposition or a bother. You're the reason that I'm here. We're going to start with something you've probably seen 100 times in 100 different math classes, and it is the Pythagorean Theorem. And we're starting here because the Pythagorean Theorem is actually going to produce something useful for us that we're going to be able to use. And in fact, by the end of the class, we'll use what we talk about today again when we define the equation of a circle and we interact with those. So you know all this, you've seen it. There's nothing really new or novel to say. The Pythagorean Theorem, it gives you the relationship between the three sides of a right triangle. And just in case you don't know what a right triangle is, it has a little right angle right here, 90 degrees, like the floor and the wall hopefully are meeting at a right angle. Otherwise, we should probably evacuate the building. So the two sides that surround the right angle, these are both called legs. And just in case you don't know the terminology, I don't like to assume things. If you know all this, just try not to fall asleep. Okay, and then this side right here, the longer side that's opposite the right angle, this is called the hypotenuse. And I just recently learned how to spell that. So there we go, the hypotenuse. And so the relationship is really super familiar to us. The traditional letters that are used for the Pythagorean theorem are the legs are labeled A and B, although the letters don't matter. You can use any ones you want. The hypotenuse is usually labeled C. And then just to make me happy, does anyone know the relationship? What is it? Yeah, what's the formula? What's the Pythagorean theorem say? Excellent. It says if you square the legs and add them together, it's equal to the hypotenuse squared. Okay, so yeah. So what Pythagoras didn't invent this. The Pythagorean theorem had been used and been around since the Babylonians and the Sumerians. They used it. But what he did is he proved it using geometry. So that is his addition to this, and that's why it gets named for him, is he's the one that kind of codified what this is. So so there's the Pythagorean theorem. It gives us this relationship. So the first couple things we're going to do is just going to mess around with this because I just want to make sure that we're used to working with square roots. One of the last things we talked about in intermediate algebra. So there's a couple things that I want to review. So example 1 on the sheet there says, for a right triangle with a leg 12 and a hypotenuse of 13, find the unknown side. Okay, so I'm just going to recycle my diagram right here. I've told you that one of the legs is 12. Doesn't matter. I'm just going to call this one right here 12. I'm going to call the hypotenuse 13. And so then what we want to do is we want to fill in the missing side. I know if you had me for intermediate algebra, we've already done this. Looks really familiar. I know you're bored out of your minds. But don't worry, we'll get through this together. So we're going to plug and chug here. We're going to figure out what the missing side is. So A, I don't know what A is. I've left that one as a variable. So I'm going to call that A squared plus B squared. That's my other leg. So I've got 12 squared. You're welcome to write that down as 144 right now if you want to. And then C squared, 13 squared is the other side, or 169. Everyone see why those numbers are where they are? Even foundational questions like that, do not be shy. Even though I'm assuming you've seen this before, if you haven't, please speak up. Okay, don't let me assume false things. So you grab your calculator, you're going to do whatever you do. So we've got A squared plus 144 is equal to 169. We're going to talk about solving equations real quick when we come back next week. But I do assume you kind of know how to do. What am I going to do to both sides of this to get the A squared alone? Yes, we're going to subtract. I'm not going to write that down. We're going to subtract the 144 from both sides. And so 169 minus the 144 is 25. Now this one's going to work out nice and relaxed because it's my example and I didn't want to think too much. What am I going to do to both sides of this in order to figure out what A is? Yeah, if this is squared, then I got to take the square root. So you hit that square root button on your calculator. We will talk more about square root equations in the 4th unit of this class. All sorts of fun stuff's going to happen. And when you take the square root, I know some of you remember that when you take the square root, you get both a positive and a negative answer. If you didn't know that, that's okay. We'll talk about that in a few weeks from now. But we don't need the negative answer because we're talking about a side. So I'm just going to say 5. So there we go. Pythagorean theorem. If you have a question about that, let me know. If you don't have a question about that, do exercise 1 right next door to the one we just did. I want you to find the, in that case, I want you to find the length of the hypotenuse. Pythagorean theorem, here we go. The Pythagorean theorem says square the lengths of both legs and add them together. So give me one of the leg lengths. Okay, so 7 squared, yes, 49. You're just a step ahead of me. Great. And what's another leg? Sure, thank you. We're putting the right number in the right place. So 24 squared. And in this case, we're asked to find the length of the hypotenuse. So just a slight differentiation from the previous problem. So yes, as I was told, 7 squared is 49. It's a little too early for me to do this in my head. 24 squared is 576. Did I hear that right? I'm an old man. I don't always hear well. So there we go. Make sure. So now c squared is going to be 49 and 576, which is going to be 600 something. Oh, look at that. That turns out to be a perfect square. Excellent. So you hit the square root button on your calculator and you get what? Okay, 25. Are we okay with working with the Pythagorean theorem? Okay. Again, my assumption is you've seen that repeatedly. I only mention it because we're going to use it now to have some usefulness for us in algebra. Okay, so I just wanted to resurrect that for you. So what we're going to do now is we're going to take this little bit of knowledge that you've had from prior math experiences, and now I'm doing something, this is probably the new thing that we'll do today. Okay, we're going to talk about the distance formula. So I'm not assuming you have seen this before. If you have, again, that's better for you, but that's not my assumption. What I want to have the ability to do, because we are going to talk all semester about graphing, we're going to do more graphing than you ever thought was possible. And so I want to, on this graph, I want to be able to find the distance between any 2 points. Okay, so for instance, I'm just going to label, I've given you a grid there. There's nothing special about these points or where I'm placing them. I'm just drawing them far apart in my grid. Here's a point. I'm going to call that point X with a little subscript 1, Y with a subscript 1, just to differentiate it from this point over here, which I'm going to call X with a little subscript 2 and Y with a subscript 2. So in case you're not familiar with math notation, these are not exponents. This is not telling me to square anything. These are subscripts. They're just saying this point is different than this point. Okay, I don't want to use other letters. So I'm recycling the X and the Y just with different subscripts. Everybody with me on that? Okay, so I want to know, let me get a different color just to be fun here. So I want to know then, what is the, that's not the best straight line, but it's going to have to do. I want to know what is this distance D between these 2 points. And I want to be able to do that for any 2 points that I have. And so the Pythagorean theorem applies here because this, our Cartesian coordinate system is also called the rectangular coordinate system because everything is right angles, and we have right angle here in our triangle. Just as an aside, when you go to pre-calculus, you're going to talk about a circular coordinate system. That is a lot of fun. There's other coordinate systems. Life is great. but we're just going to stick with the Cartesian coordinate system in this class. So here's what we're going to do. Since everything is at right angles, I'm going to connect these dots with a triangle. That's very lovely. I'm getting my best work here today. So the challenge for us then is, am I able to determine the lengths of this horizontal side and this vertical side with these points if I know these values? And the answer is going to be yes. I wouldn't ask the question if the answer was going to be no. That wouldn't be very much fun. Let's deal with the vertical distance just because, for no reason. Okay, so I've got my vertical distance here. I know that the y value up here is y with a little 1. I know the y value down here is y with a little 2. What can I do to figure out how far up or how far down I'm traversing as I'm tracing the side? Any ideas? No? Okay, well, that's good. It's good that I'm here then. Okay, so what we're going to do then is, if this y value, y2, this is the y value of all this right here, this side, and then it goes up to this y value, this side right here is y1 minus y2. It's just the difference between the two y values. How far have we ascended as we climb up? If you're a mountain climber, how far have we ascended? Well, we've ascended from the y value where we started to the y value where we end. Better? Do you see it now? Don't let me move on. Okay, great. I'm doing an amazing job then. So then my horizontal distance, as I go this way. Now that you've seen what the vertical distance is, any hypothesis on how I can figure out how far left or right we've gone as we've climbed between these 2 points right here?
X1 minus X2.
Sure, that sounds great. X1 minus X2. It's the X value that I have right here minus the X value here. That's how far left or right that we have gone. So now I have a right triangle. I have the thing that I'm concerned about, this blue line, the distance between the 2 points. And then I have the legs of the right triangle that I know right here. This allows me to come up with what's called the distance formula. So using the Pythagorean theorem, the Pythagorean theorem says this, that I take my legs and I square them, I add them together. So my first leg is x1 minus x2, and I'm going to square that. Okay, that's the first leg. This is the Pythagorean theorem that we were just using moments ago. Plus y1 minus y2, and then I'm going to square that. So this is one of my legs right here. This is the other leg. The distance between the points is the hypotenuse. So that is d squared. Excuse me. One more step, and you're going to have what's called the distance formula. Yes, you do have to remember it. That's why we're going to practice with it in here, why you're going to practice with it on the homework. So you'll remember the distance formula. And so I'm going to take the square root of both sides like we did a moment ago. And so when I do that, square root here, square root here, here's the distance formula. And if you don't mind, I'm going to put the d for distance on the other side. I'm just going to flip-flop the relationship. So I'm going to put the d right here. And the distance between the 2 points is the square root of all of this junk right here. x1 minus x2 squared plus y1 minus y2 squared. Not only is this important for your homework, for the test you got coming up, there's a distance formula problem on the final exam. Okay, so put a little asterisk by that. Okay, it's gonna pop into your life several different times. So this is worth remembering. Not only will we use it for distance, we're going to use it later in the semester when we come up with a formula for the equation of a circle. A question you might be having is, hey, Kirkster, does it matter? I know you've got x1 minus x2. Could I have done that reversed? Could I do the x2 minus x1? The answer to that is yes. Since you're squaring it, it doesn't matter what the sign is. Anything when you square it becomes positive. So it absolutely, you can't goof it up by subtracting things in a different order than I do it. Okay, we'll all come up with the same thing. So here's my first example that I'm going to do. It's example 2 on page 2. I get to turn a page in my 3-ring binder, so you only have all of these pages left in the semester, everybody. Mess. So example 2 says this. We are going to find the exact, we're not going to use our calculator, we're not going to come up with a decimal, we're going to find the exact distance between these 2 points, -8 and 4, and 3 and -2. Come up with the exact distance. All right, well, we'll worry about the exact part of this a little later. Let's just throw this down into the distance formula. So I'm going to subtract my x's. What's the expression for subtracting my x's? What am I going to do? Sure, x1 minus x2, so put numbers in. What is it going to look like? Thank you. -8 minus 3 squared. One thing I would just remind you of, I'm sure an instructor has told you this before, when you are subtracting with negatives, be super cautious. Because if you would have said, and this would have been perfectly legitimate, if you had said 3 minus -8, it's not 3 minus 8 or -5, it's 3 minus -8. What's 3 minus -8? What does that become? 3 plus 8. Okay, so be super careful when you're subtracting and you've got negatives. Okay, plus, and then what's the expression for subtracting my y values? Sure, just what I said, 4 minus -2, so 4, then I subtract -2, so that becomes 4 plus 2 squared. Everybody comfortable why that's 4 plus 2 here? Now, the rest of this is arithmetic, so I'm not going to bore you any more than I already am. So -8 minus 3 is -11. -11 times -11 is 121. 4 plus 2 is 6. 6 times 6 is 36. And I have the square root of 157. Making sure that I have an exact answer is making sure that I can't simplify this at all. And all that entails, again, this is just review of intermediate algebra. This is from the very last unit of intermediate algebra, but I know we had Christmas break in between and we forget everything. So what you do is you take your calculator and say, okay, do any of the perfect squares divide into 157? So I don't know. I didn't bring a calculator, so I'm gonna use my phone calculator. So I'm just checking out 157. Well, 157 is odd. It's not going to divide by 4, so I don't have to worry about it. So I'm just going through the perfect squares. So 157 divided by 9 doesn't work. Gives me 17.4, so that's no good. 157, the next perfect square would be 16, but that's even. I don't need to worry about it. The next one's 25. Well, that's clearly not going to work, but just to prove it to myself, 6.28. And then so you try and try and try to see. I'm going to try one more. I'm going to do 157 divided by the next one, which is 49. And it's 3.2. So I don't think that there's a perfect square factor of this. So that is the exact answer. I can't simplify this radical in any way. By the way, in case you're like, what in the world is he doing? Perfect square factors. That's crazy talk. Well, let me just remind you. One quick example, if we got the square root of 45, hopefully this jogs your memory in case you didn't know what I was talking about right there. Square root of 45, well, I can't take the square, well, I don't have a perfect square root of 45, but 45 has a factor that's a perfect square. What is it?
9 times.
Yeah, it's 9 times 5. Then we use the product rule of radicals, and the product rule of radicals says you can consider these two things separately. So I can take the square root of 9 and get 3. The square root of 5 is an irrational number, so it stays square root of 5. So that's what I was trying to do right here with the square root of 157, but I didn't have a perfect square factor. So this is done. It's the exact answer. I'm settled with it. But always simplify radicals if you can by looking to see, is there a perfect square factor of this number right here? So try your hand at this. The next one, exercise 2, right next to it, you're finding the exact distance between the points 7, 5, and -1, 1. All right, I'm going to get started on this. Check my work with your work. If you're still plodding along, that's totally fine. So here we go. My distance is going to be the difference between the x's. So that's 7 minus -1, so 7 plus 1 squared. And then 5 minus 1 squared. So what you should have under the radical, 7 plus 1 is 8. Or if you did it reversed, if you did -1 minus 7, you have -8. Either way, you should have a 64 right here. 5 minus 1 is 4, so 4 squared is 16. Again, if you did 1 minus 5, you got -4. -4 squared is 16. So we get the exact same values. Doesn't matter what order you subtract anything. And then 64 plus 16, what is that, 80? Oh, great. It does have a perfect square factor. I knew I had one in here for you to practice. So you go through and you say, oh, the perfect square factor of 80 is 16. 16 times 5. Square root of 16 is 4. The square root of 5, that's an irrational number, so we'll leave it square root of 5 since we want the exact answer. I do not want a decimal approximation from the calculator. Any questions about this? There's a few things in here that you could ask a question about. Yeah. You always take the greatest amount. So probably what you're referring to, correct me if I'm wrong, probably what you're referring to is for square root of 80, you said 80 was 4 times 20. Correct? Is that what we're referring to? Yeah, great. So if you did this, if there's others in here, which I'm anticipating there is, that's why I was asking if there was questions. Okay, so you notice you got the perfect square, you've done a great job, but then this number here, 20, you can ask the same question of 20. Does 20 have a perfect square factor? So there's nothing wrong with whittling it down and getting 80 into a number that's more manageable, like 20. Okay, so then you do it again. So this 4 right here, I'm going to cover it up. What's the perfect square factor of 20? It's 4 times 5. Whoops, I just erased that. And now you can do the product rule of radicals, or you can see that 4 times 4 is 16, which I got over there. So either way, we should dive into the same answer. Okay, great question. I'm really glad you asked it. So again, don't be shy. If you have a question, okay, I love questions. It means you're processing the information and you're working things out. We doing okay? Anything else that we need to address? All right, one more thing then from this section, and then we will be done with what we're going to talk about in section 1.1. So that is how you find the distance between 2 points. Please practice that. I'm going to ask you to do that at least 2 times on the test that you take on whatever day the test is. I don't know where I put my calendar. Oh, here it is. The test is going to be on January 18th. So when you take it, you're going to have to use the distance formula a couple times for me. So if you feel confident with it, you're going to be doing great going into the test. The other thing is, okay, I've got my same 2 points, but this time instead of finding the distance, I want to find the halfway point. What's the midpoint? What is this point right here that I'm going to label M because I'm super clever for midpoint? What's the midpoint between those? Well, this is a little less strenuous to do. To find the midpoint, what we're going to do is we're going to find the midpoint as we go horizontally. We're going to find the midpoint as we go vertically. So this is a little bit easier. The midpoint between 2 points is this. Basically, you're just going to find the average. So the midpoint in the x direction is x1 plus x2 divided by 2. That's going to be the x coordinate of your midpoint, comma. And then y1 plus y2 divided by 2, that's going to be the y coordinate of your midpoint. So my last example from this first section, example 3, the points that I gave you or gave all of us in the first example, -8, 4, and 3, -2. This time, instead of finding the distance between them, I want to find the midpoint between them. Okay, well, here we go. I'm going to use the letter M for midpoint so that I know that it's the midpoint, and you know that it's the midpoint, so I'm labeling it. So the x coordinate is going to be -8 plus 3 divided by 2. The y coordinate is going to be 4 plus -2 divided by 2. And then you just got to do that arithmetic, and you're going to be done. -8 plus 3 is -5 divided by 2 is just -5 over 2 or -2.5 if you prefer decimals. 4 plus -2, that's 2. 2 divided by 2 is 1. So this point right here, -5 halves, comma 1, that would be the point that would be exactly midpoint between these two things right here. So as a last problem from section 1.1, if you would do the same thing in exercise 3, if you would go back to those points from exercise 2 and then find the midpoint between them. Yes. That's a 5. I am just terrible at penmanship. Kindergarten was a struggle for me. But if it was a 6, you'd be 100% right. We would definitely always reduce our fractions. Okay, I'm going to get started with this. If you're still rolling along, let's check our answers at the end. And then if you've got any questions, this is the last problem from section 1.1. Okay, unless you have anything more that we need to talk about. So I asked for the midpoint, M, the midpoint. So the midpoint is, for my x's, is 7 plus -1 over 2. For my y's, it's 5 plus 1 over 2. So my midpoint becomes 7 plus -1, that's 6 over 2, that becomes 3. And then 5 plus 1, that's 6 over 2, so that's 3. So the midpoint is 3, 3. Anybody get something different that we should talk about? Okay, well, I feel great about this section. I'm going to do really good on the test, but that doesn't matter. I want you to do good on the test. So if there's anything, let's talk about it. If not, I'm going to stop this recording and then we're going to do another one.